Alright, so we're going to be doing equations of equilibrium and free body diagrams today. And our problem of the day is to find the normal force of A and the normal force of B of a 25 kilogram roll with 35 millimeter radius. Okay, got it? Alright, so let's attack this problem. Alright, so we're going to be drawing a free body diagram. And our first force is going to be the force of the weight of the roll, which is going to be down due to the force of gravity. And our normal forces of A and normal forces of B are going to be perpendicular to the surface of A. So that means it's going to be going this way. And then that means it's perpendicular. So, alright, so those are our normal forces right here. Alright, so that's our free body diagram. So next up, we're going to be breaking up the forces. So we know that this is going to be a 30. This is going to be the 30 angle. That's what is given to us right here. And so then we can break this up into a triangle right here, right triangle, because it's easier. So since this is 30, this is going to be a 90 minus 180 is going to be 60. This is 30. This is 60. This is 30. Alright, so this is 30, this is 60, and that means this is 60 over here, this is 30 over here. Okay, now that we've broken those up, we're going to be finding the weight of the gravity. The weight of the gravity is going to be the mass times g. Okay, so the mass is 25 kilograms times the acceleration of 9.8 with g. So that means the weight is going to be 245.25 newtons. We'll write that on the side right here. Alright. Next, we're going to be breaking up the forces. So our first force is going to be the sum of y, which is 0 because it's at equilibrium. And we know, if you look back at here, okay, so in our y directions, this would be going down, so that means it's a negative y. So we have negative g. And if we look at this y, it's going up. And in order to find that y, we're going to have to be doing, it's going to be plus a cosine of 30 right here. So let's look at 30 right here. It's cosine. And then we're going to do plus b cosine 60. And that's finding this one right here. Alright, now that we have the f of y, now we're going to find the f of x. And since it's at equilibrium too, it's also 0. Alright, to find the x, this is going to be in the negative direction, because that's the way the x would be going. This is going to be in the positive direction. B of x is going to be going. So that means we're going to have a negative a sine 30 plus a b sine 60. Okay, solve for b. So that means a sine 30 equals b sine 60. And then we're going to divide a sine 30 by sine of 60 to find b. Okay. Alright. And so we're going to plug this into our f of y equation up here to find a. Alright. So here's our f of y, just for reference. So it's going to be a cosine 30 plus a sine 30 over sine 60 cosine 60 minus g. Alright, so we're going to put the g over here, take out the a from this, alright, So we have G. What's a G? Sorry. So it's going to be cosine 30 plus sine 30, all of it multiplied by 60, or my cosine 60, equals to A. So since we know G, just plug that in, divide it by all of these sines and cosines, and you are going to end up with 212.393 newtons. Put it into significant figures. You're going to get 212 newtons equals A. So we're going to plug that into our N of A right there. Okay. Alright. So now that we have our N of A, we're going to plug it back into our f of x equation, which was A sine 30 sine 60 equals to B. Plug in our A, and then after you plug in your A, we should get B equals 123 newtons. Alright, and that means we found all the normal force of A, and we found the normal force of B. Alright, congratulations. I hope you guys have a wonderful day. Thank you.